So it's a very nice chance to come to France, Paris, to know you guys. And I, on behalf of Unitree in whole European, and my background is a little bit business part. So for the technical issues, maybe I will invite my professional engineer to answer. So I will introduce some basic information from hardware and software and some open source informations about Unitree Robotics and how we build our ecosystem. So I will quickly start. Firstly, Unitree is a manufacturer focused on the humanoid body building. Like a mobile phone manufacturer, we focus on building the reliable hardware body. And based on this hardware platform, we find our ecosystem partners who building their brain, their knowledge put into our humanoid. For example, from some commercial part, we are marketing share by now is like 16 to 17%, because we cooperation with a lot of university, academy, research center, and some AI innovation department from some interface level company. And our core capability for the robot self, the most important things, we build our motto, design of the PC board, battery, hologram of sporting, receptions of our robot feelings like eye version, locomotion, computer version. And our technology innovation is that we are not only focused on the robots' performance by now. We want to put the humanoid into real human life to do real tasks. So that's some important thing we discover by now. And I also want to take this chance to do more communication with all of you guys. So this is a quick overview about our history since 2013 to 2025 by now. Our original is doing the quadruped, four-legged robots and supply to the most of the university, the professor, the lab, as a hardware platform, verify their hologram, use this mobile robot dog. But as you know, with the very hot, the winds bring to globally like ChatGPT, something like DeepSeek, this large language model. And we found it's a very, very good chance to start build a humanoid, the human shape. So in 2023 to 2025, we quickly joined this racing game. And the main topic today, I will introduce the humanoid from Unitree first. The robot dog, if you want to know more detail, welcome, contact me offline after this shortly introduction. So for humanoid, we have a big size, the human adult size, 1.8 high. This is H1. Some university in European, America, like ETH, like UCSD, MIT, they use this to verify the locomotion, to verify the project, do some household, do some autonomous solutions in the lab first. And this is the most popular mode by now. We call it G1. It is 1.3 high. I really want to bring one real robot here demo, but due to the production limited in China because global requirements increase, so it's hard to bring one from our factory. But next time, if we have chance to bring this to European or France, we will share with each other and invite everybody to play. So for these robots, we have different joint in hardware part. The basic version is 23 freedom. Each hands have 5 to 6 freedom if without fingers. Each leg with 5 to 6 freedoms. And the next step, we will input and improve more freedoms, like neck, like waist, like ankle. We can make more freedoms. Then he will much more flexible to reach different tasks. For software part, we do a lot of simulation because it bases on the Ubuntu 22, Linux. It is open source. You can use C++, Python to do the secondary developing. Use Gazebo, Mojoko, and to the sim to real, real to sim, or sim to sim. And after training on-site, collect the data in this virtual environment, then we can put it in the real environment. So there is some demo video I will show later. And go back one more topic for hardware. We, like mobile phone, we put some microphone, speaker, depth camera with computer version, and some very long life endurance battery inside. The computer version help him to recognize the environment, recognize the people, to do autonomous obstacle avoidance. The micro speaker make it more reaction with the human being. So if we talk with him, he will understand you what you do. By now we cooperation with some company like OpenAI, DeepSeek, and put their large language model inside. For example, I programming in advance, shaking hands or dancing in advance with the robots, and I talk with him. After he used the microphone and speaker, listen my language, he will understand. He will dancing for you. By now, a lot of remote, but in nearly 2 or 3 years, we will slowly to reduce the remote use and much more real AI functions inside. This is some round products, the arm, the LiDAR. So I also very proud of to invite everybody here to take this chance. Go into our website. The domain name is www.support.unitree.com. We publish all these development documents on the website, the SDK, the API, and you can use this interface service to some debugging, to do some experiment based on the robot dog or humanoid. And you can see the humanoid open source and the quadruped robot arm. And all the specifications already show in this web page. We open source some teleoperation use case. We open source some dancing movement. We open source some kung fu movement, and we are all open source this day by day in this year. So if you have this kind of project, you're just using our standard coding open source, then you can do all these case by yourself very, very easily. And this is the G1 open source menus, support.unitree.com if you find this website. And this is our GitHub link with a lot of hologram to debugging different motion control holograms. This is a little demo from UC San Diego. Just 2 days ago, they put the fingers and customize the head with their camera to do some household. But it is 3 times video, not the 1 times video. Yeah, I think they are also open source this project. You can find it from this website. Yeah, hope you can enjoy. By now you can see the motor control, the accurate, the stables, they are a little bit shaking. So that's the challenge you also need to do. Make it more stable and more reliable. Yeah. The finger can change to the 5 finger and any fingers you want, maybe 10 fingers. This is some other environment in the house. Maybe future where people will need these kind of functions. The finger made by ourselves, human body made by ourselves. So we are very good at to build this kind of hardware. And we need to find more ecosystem partner, build the big brain, build the small brain to training the robots. And the next demo is about teleoperation. The whole project already open source. And this is the boxing we after training.
How to teleoperate it?
Teleoperate. Yeah, so for this very interesting boxing game, very excited me is that in June we will globally first to public the online stream video for humanoid boxing. So also welcome to focus on us. Yeah, you can see the online video and is a live stream. So you can see from this video, by now our strategy is build the body stable first, like a baby. We training the robots walking stable, running stable, and do some movement. So next stage, we build more intelligence inside because the hardware stable and reliable capability is most important part by now. So we want step by step. We don't want to do a lot of over range, over capability things by now. A lot of humanoid, they say can do some household, but by now the household it is very far away because dangerous and different people, they have different requirements for the robots. Once the robots hurt the children, broken the property, it is very dangerous. So we do some performance like this show for entertainment first. This is a much more safety way to go in, to help the humanoid industry growing up. So some our core capability, for example, in China we have a very strong supply chain. and the factory can 2 or 3 days to collect different components, different material, and 1 or 2 days we have some employees to quickly build a humanoid, and one day we can build a 200 or 300 robodog, 3 to 50 pieces humanoid. So this is something we can load on the coast, make everybody have a chance, have a robots in their hand, in their labs for their project. And for most important thing, we also do slowly by the education area, because compared with the real social environment, for competition area is much more safety for humanoid industrial. Why? Because we use the robots to play football, join the robot cup. It is training these teams to put their knowledge with the robots inside. By now, we also participate IROS for the with the robot dog and the humanoid. We call the quadruped challenge. So we were setting the route we were setting an environment for this competition. For example, backside we were setting an environment. There is a regulation whose robots most quickly, most shortly to go to the destination and who win the award. So these professor students, they have passion to join these games, to training these robots. And for this competition, all the robots autonomously solutions, no any remote control. Next, we will show another things we do. In some Chinese gala show, we do the performance. So this we call swarm control. And this is for some Winter Olympic opening ceremony. If you use one robot, it is very simple. But how you make all the robots, 10 pieces, 100 pieces, 1,000 pieces, connect with each other, make all the movement in the same time and the same movement. This is also very challenging things we do. So this is some Super Bowl show, human with robots. So future, these robots will go to everybody's life. And all the robots control with one remote. No need 4 or 5 or 4 people. So this is for some entertainment purpose by now. Is many things for humanoid can do, because a lot of people think how commercialize the robots. Nobody will afford robots by self if know some project from the government or university. So for entertainment, it can speed up everybody get very closely, get very familiar with the robots. So this is our strategy. We think this way by now is already very successful, because in China, everybody use this robot for some demo, for some playing, cool play, for some landmark building. Everybody take a photo. So and some Asian games to help athletes do some transportation with some stuff, because robot dog moving and with payload on the top. You can put a 10 kilogram, 20 kilogram, 40 kilogram. Also, this is some. Also, this is a 1.8 meter high humanoid dancing together. We can take the few minutes to enjoy. So in this show, once the humanoid dancing on the stage without any remote or autonomous, only go on the stage and downstairs of stage we use a remote to control, make it more stable. And once we public some social media, also get a lot of reviews and very hot. We cooperation with the NVIDIA and use their ESAC software solutions to training the robots together. And not NVIDIA, also other chips company, we already cooperation, use their chips to customize only for the humanoid. We cooperation also with some interface level, the innovation department, and they training and feed up their robotic engineer and the robotic business. So this is quickly introduce about our humanoid. If you have any question, I would like to quickly answer.
Question?